In today's lesson, we are going to introduce the concept of inheritance. So in object-oriented programming, inheritance is the mechanism of basing an object or a class upon another object or a class, retaining similar implementation. Also defined as deriving new classes from existing ones, such as a superclass or base class, and then forming them into a hierarchy of classes. To fully understand the concept of inheritance, we are going to do multiple examples. We will start easy with an example of creating the classes that will represent the inheritance in the animal kingdom. To be more specific, we will create the inheritance that will define all these animals: a dog, a cat, an eagle, and a shark. So we can start by using the right tools in order to define the inheritance. In order to define the inheritance, we are going to work with schemes, with diagrams, and a great tool that I have been able to use successfully is this one. Okay, so we are going to go with this one. So please open the link. Okay. With this tool, you would be able to create multiple type of diagrams, shapes, and many things that will help us in order to prepare to code. Okay, for the moment, what we are going to do is just to open a file. Okay, you are going to download this file, and you are going to open it through the file, open from, device, and you are going to open the file you have just downloaded. Okay, you open it in this same window, discard any changes that you had already done, and you should be seeing just this. What we have here is a very basic structure of the hierarchy of classes that represent the animal kingdom. It's a very basic representation. This is not meant to be scientific. It's just for the sake of trying to understand how the inheritance works. So what do we have here? The first class to highlight would be the base class. In this case is the animal class. All the elements that we are going to classify, dog, cat, eagle, shark, belong to the animal kingdom. So the shared class between all these animals is just that they are animals. So this is the base class, and that they belong to the animal kingdom means that they are going to share some properties, and they are also able to do some actions. As the shared properties, in this particular case, what I have defined is that all the animals are going to have a lifespan that will be different depending on the animal. All the animals will have a weight. Again, it will be widely different a weight of a cat from a shark, and all the animals move to a speed. As behaviors linked to that class animals would be that all the animals breathe, either by pulmonary breathing or branchial breathing. All the animals eat. They eat stuff that they convert into energy so they can live, and all the animals can move. Okay, so we have defined this base class that it will be some common properties and behaviors that all the animals are going to have. Okay, and what do we have in this new layer? Okay, we are creating derived classes that are inheriting from the base class. So what do we have here is Okay, I can classify the cat and the dog as walking animals, and I can define that, well, a shared property between all the walking animals is that they are going to have legs. Okay, so they have a property of the number of legs, and as a behavior, they would be able to walk. Okay, and aside from this property and this method, it will inherit all the properties and the methods from its base class. So if we categorize a dog and a cat as walking animals, they not only will have these behaviors and these properties, but also they will have the lifespan, weight. They will also have the methods that are defined here. Okay, another derived class that we can identify for our current example is the flying animal. Okay, in this case we need a flying animal class to classify the eagle, and as a property of the flying animal, well, it has wings. Okay, so there is this property here, and as a behavior they can fly. Again, aside from this property and this behavior, they are inheriting from the class animal all the properties and all the behaviors there. And we are doing the same for the case of the shark. I have created this category, this derived class swimming animal. In this case, I have not been able to identify a property, but as a behavior, a particular behavior only for this particular class, that they can swim. So the next step would be just to just to create the classes for each of the animals that inherited from the right class. So we are going to do it together. Okay, so let's go here, and we will start with the dog. To make it easier, what we are going to do, we are going to select through Control, and we are going to copy and paste, and by this way we are creating the new class, and we are creating dog, and we are removing the content here of the properties. Wait, okay, let's leave it like this first, and let's leave it also the properties like this. Okay, so what would happen here is that well, the dog, it should derive from the class walking animals. So what we can do is just to duplicate this object, move it to here, and when it's highlighted in green, this point, you can press and drag to create the arrow, and you can connect it with the class dog. Okay, now we are going to classify the rest of the classes. So we will go with cat, and these would be the two classes that will derive from walking animal. Okay, now let's classify the eagle. The eagle will belong to the flying animals. And finally, the shark would belong to the swimming animals. Now, as exercise for you to do, just think about what kind of properties and methods we can define for all these classes. Okay, so go ahead, think about it, and come back when you have something to propose. And what I have to propose would be like this. Okay. So what I am proposing for the cat is that the cat will have extra lives. Okay, we are doing a video game, so we can break the rules of reality and give the cat some extra lives. And the cat also could have night vision. Okay. About the dog, let's give it the property of friendship, and as a behavior only for the dog, super smell. For the eagle, I have thought about giving him a range of vision detection, and as a behavior, it can perform a flight attack. And for the shark, well, property of the number of humans that has eaten, and also as a particular property only for the shark, the ability to smell blood. Okay, so in short, this is what an inheritance structure should look like when you define your elements for your projects. Okay, you will create something similar, but for your particular projects. And the exercise that you are going to do right now, you are going to create the structure of classes, the full inheritance to classify the next elements. We are going to classify a car, a bike, a bicycle, a ship, and an airplane. As a base class, you are going to use the base class vehicle. Okay, the vehicle will have 3 properties: speed, weight, and load, and it will have two behaviors: to move and to load an item. Okay, so now go back to the UML structure. You can use this same structure just for the case of vehicles. Okay, and what you should do is just to create what we have done for the animal kingdom, but in this case for these vehicles. So you are going to create what you consider to classify all these vehicles. Okay, so you will create what it belongs to classify all the different vehicles. So please go ahead and come back when you have something to propose. If you have finished your UML diagram, it should look like similar to this. It doesn't need to be exactly the same. There is no wrong answer. The inheritance structure that you have made, as long as it makes sense, is it good? Is it okay? In my case, what I have identified is I have 2 categories here, that it's motor vehicle and human powered vehicle. Okay, for the human powered vehicle, I recognize the bicycle, and for the motor vehicles, I recognize all the others. Okay, inside the motor vehicle, what I have been able to recognize, it has been a road vehicle, a water vehicle, and an air vehicle. And finally, I have been able to classify inside road vehicle the car and the bike, in the water vehicle the ship, and in the air vehicle an airplane. And in the case of the human powered vehicle, I have classified the bicycle. As I said, you might have the different, but as long as it makes sense, it would be a good solution. Now what we are going to do is that we are going to create the scripts for the previous hierarchy definition within a new Unity project. So let's create a new Unity project, okay? And we are going to download these free 3D models of a car, a bike, a bicycle, a ship, and an airplane from the Unity Asset Store. So click on the link on each of the 3D assets and add it to your project. Okay, once you have imported all the 3D assets, let's create a little bit of order here. We will create a folder, for example 3D models, where we will place just all the assets except the scene folder. Okay, now let's check that we have everything we need. That's it. Take a moment to put them just in order in the scene. Okay, so we are going to just scale it and make them. Okay, so let's start by resetting all in the 0, 0, 0. Okay, good. And we are going to just define different sizes. For example, we will take the reference, the car. Let's take the reference as the car. Okay, so the bike is going to be smaller. Okay, so now that we have properly imported and placed it on the scene all these 3D assets, let's going to create the hierarchy structure of classes. Okay, and we will start creating the class vehicle with its members, variables, and methods. So go ahead and implement the class vehicle with the speed, weight, and load as a properties, and the methods move and load. Just leave them for the moment empty. Just declare it and leave it empty. Later on we will fill it. Okay, so go ahead, just do it. So it should look like this. You have created a new folder in the assets folder of the Unity project, where you would have created a new script called vehicle. And in this script you have defined the public variable members, the speed, weight and load. And you would have created two methods that right now are not implemented yet. That it's the move method and it's the load item method. Okay. Next, what we are going to do is to create the rest of the classes, inheriting each class from the right parent. Okay, so we are going to do an example of inheritance with motor vehicle, and you would do the rest. So let's go back to the Unity project and let's create this time the script motor vehicle. Okay, so now let's edit the script. In order to define inheritance, you have this section right here just after these two dots. Okay, so here in order to establish that this motor vehicle inherits from vehicle, the only thing that we need to do is just to type the name vehicle just right here. So motor vehicle right now is inheriting from a vehicle all his public and protected members, alongside also his its public and protected methods. Okay, and here in motor vehicle we are going just to implement its public variable members and its methods. Next, to keep organizing our code, we can create a folder structure, okay, where we will place all these all our classes. That kind of matches the hierarchy structure that we already have. So here we would place also motor vehicles, and we would move this folder, this script, sorry, into this folder. Okay, so this way we are just ordering the whole thing so it's easier to navigate. Okay, so now do the rest of the scripts and the hierarchy. Okay, go ahead. Okay, if you have completed the implementation of the hierarchy of classes, it should look similar to this. We have first created our vehicle script, vehicle class, okay, and after that we have created the rest of the classes. Human powered vehicle that inherits from a vehicle, and the bicycle here that inherits from the human powered vehicle, and it has the properties and the methods that we have defined in the diagram. The same happens with the motor vehicles. The class motor vehicle is here with its public variable members and its methods, and for each subclass, air vehicle, road vehicle, and water vehicle, just defining the right inheritance. Okay, water vehicle inherits from motor vehicle, and it has the helix, and finally the final layer, final nodes that we have created, just the ship from water vehicle, the bike and the car that inherits from road vehicle, and and the jet and the airplane that inherits from air vehicle. Okay, and once we have our scripts, it's time to assign the scripts to each of our 3D assets. Okay, so just add the right component for each 3D model. Okay, the bicycle will have the bicycle script. As you can see, the bicycle has the properties inherited from a vehicle: speed, weight, and load. Okay, the first 3 ones. And the properties from human powered vehicle, the difficulty and age. Okay, difficulty and age right here. And the last 3 belong to the own class bicycle, that it's the color, the type, and the years. Okay, so this is how it looks, a script that it's inheriting from inheritance structure and inheriting multiple properties. Okay, so we would do the same for all the other elements. For the ship, let's add the ship script, and we are getting something similar. We are getting from vehicle speed, weight, and load. From motor vehicle, we are getting the power and the consume. And from the water vehicle, we are getting the variable member helix, the property helix. Okay, so here we have our inheritance, our properties inherited from the whole hierarchy structure. Okay, let's do the same for car, for bike. Okay, let's add a car, the car. Okay, the same as the ship, in the section that the last property that inherits from road vehicle, its tires. Okay, and the bike. Okay, and finally the airplane. Okay, so we have assigned our classes, our scripts to the different objects that we have on a scene. And the advantage of creating this hierarchy of classes is that there will be some methods, properties, and that you only have to define once, and everyone that it's inheriting from that particular class is going to take advantage of that properties and methods. Okay, So here you have a code checkpoint in case that you got lost. You can download the whole project from here, and so we can synchronize together and go forward. So next, what we are going to do is that we are going to implement the method move of the root class vehicle. Okay, so what we are going to do is just in the root class we implement the method move in order for anyone who inherits from vehicle can benefit from the implementation of the method move. Okay, so in our code we are going to implement the method move. Just copy paste this code. Okay, let's go to the Unity project and type the code to implement the move here. And what we are going to do, we are going to move all the objects in this particular direction. Okay, and what we are doing here is that we are accessing to the reference of the game object. Okay, so we are accessing to the transform of each one of them. Okay, and once we access to the transform, we are able to modify it. So we access to the transform, we access to their position, and we move them in that particular direction in a certain speed. Okay, for each second, and we adjust that value with the fraction of the second that it's performed in each frame, because this move is going to be called on the update method of the game objects. So let's go and call the move method on the update of each one of the game objects that we have on the scene, for the ship, the bicycle, the car, the bike, and the airplane. Okay, so we are running move on the update of the bicycle, we are running move on the update of the plane, we are running move on the update on the bike, on the car, and finally on the ship. Okay, so for all the instances that we have right here in their update method, they are calling the method move that it's inherited from the class vehicle, and they are taking advantage of the unique implementation of that method, so they don't have to implement it again. Okay, and the only thing left to do is just to assign some speed value. Okay, so we are going to set that value to, for example, 5. If we have properly changed everything and we press play, we should see all the game objects moving farther away from the camera. Okay, right now just play a little bit around, assigning different speeds. Go ahead. As you can see, I have assigned different speeds and I am getting different types of movements. The ship is the slower one, the airplane is the faster one. Okay, so far what we have done is just to use the method move that all these elements inherited from vehicle in its update method. But there should be a more efficient way to apply move to all vehicles. You have to consider that right now we have had to type move for all the updates in all the scripts. Can you think about any other way that we can move without having to type again and again the move method in the update? Just think a bit about it and come back if you have a solution. Okay, so some of you may have thought about, okay, maybe we can just move in the vehicle, just right here, and since well, everybody is inheriting from vehicle, and it's using its inherited methods and functions, since this is a method that it's also inherited for everybody else, then we only need to use this move right here, and everybody is going to update and move it. Okay, so we can make this test. We can just code the move call here and just remove in the others. Okay, and once we have removed that, if we proceed to play, we are not getting any movement at all. Why is that? Okay, why is that? Let's go back to the code. What is happening here is that yes, it's true that when you inherit from a class, you are inheriting all the public and protected variables and public and protected methods. But if you don't define the instruction that defines as protected or as a public method, these methods are going to be just private by default. So this right here is the same like if we have typed the word private. So this is a method that only is going to be used inside vehicle. It's not going to be inherited by anyone else. Okay, but we are interested that everybody else can inherit the method updates, because we don't want to repeat the move instruction again and again and again. So what we need to do is just to say that, okay, this is a protected function. That a protected function, what it means, a protected function? It means that only the inherited classes are going to have access to it. So the difference between public, protected, and private, we can see, we can check it right now again. The public is that this method, it's not only available for all the inherited classes, but for everybody else. So anyone from the outside, as we saw on our external modifier script, can modify it from outside, can call it from outside. So in this particular case, we are not interested, because update is something that must remain kind of private to the whole thing. The other option that we have is protected. Protected means that it cannot be accessed from the outside. So that script external modifier won't have access to the protected. But all the members, all the classes who inherited from vehicle would have access to that method. Okay. And finally, the instruction private means that this is only for the use of only this class. Okay, that this method, even if you inherit from vehicle, you won't have access to this method. So in this particular case, we are interested in that protected option, because we don't want to offer it to the outside, but we want that all the inherited, all the classes who inherit from vehicle can benefit from this one. Okay, but we still have one little problem, is that okay, we are inheriting from vehicle, but here we have a private. What it means, a private void update. So right here, what we need to do, since we are inheriting the update from the upper class, we can remove the update method in all the classes that inherit from vehicle. We also have to eliminate the update method from all intermediate classes on the hierarchy. Okay, so that's road vehicle, water vehicle, okay. So once you have removed all the update methods, you are making for sure that the only update that it's being called in all the inherited classes is the update we want, the update from vehicle. Okay, if we did it right and save and go back to the Unity editor, we should recover the movement. Okay, as you can see, the movement except the car is doing fine. Let's check what's happening with the car, and we see that we have still our private update that, okay, it's taking this instead of what it's being inherited from vehicle. So let's remove this update, and yes, right now if we play it again, the car is also going to use the update method that it's inheriting from vehicle, and that's it. But this approach that we have done here, it might become problematic, because maybe we are interested that in the update method of a specific class, okay, to do some particular action that only belongs to that specific class. For example, just assume that we need to check the brakes, if the brakes are being pressed, just right here in the update. Just imagine that we are checking something all the time, that okay, is the driver pressing the brakes, and right now the problem what we have that is that we cannot use the current structure, because the update that we are getting is the one that we are inheriting from vehicle, and we also cannot implement the check the brakes function right here. We cannot do it because vehicle it's just the root based class, and it doesn't have to have the information about, it doesn't have to know about who is inheriting its class. So how do we do it? How we can add more functionality into our car, into our update? To be able to do it, to be able to extend the functionality of what we are inheriting from, we have the concept of virtualization and override. Okay, this methodology will allow us to extend an existing inherited functionality and well, just customize it as we need. For example, in this particular case, if for the car we need to check the brakes on the update, and what we are going to do first is in the class vehicle we are going to add the word virtual. Okay, and what virtual would allow us is the possibility to extend this behavior. Okay, so we are going to just call the update. Okay, right here in car, let's go to a car. We want to call the update, but we also want to extend it to add our own logic into the update. So in order to do it, what we should do is just to overwrite it. Okay, and what we are doing just right now is we are ignoring the functionality that comes from the inherited class vehicle. We are just overriding it. Okay, we are overriding it, and here we would be able to put the code we need for our car to work. Okay, so just make the test of going back to the Unity editor, and if you press play, the car should stop. Okay, as you can see, the car stopped. Why? Because we have just overridden what we have inherited. Okay, let's keep going. But but I still want to move. I want to still get the behavior of the update of the vehicle. Okay, then you have the option to, through the keyword base, access to the update of vehicle. So what would happen here is, okay, yes, I am overwriting the whole thing, the whole update, but inside it I am calling to the base class. If we go to the definition, or press F12, or just mouse left click, go to the definition, we would go to to the vehicle class, to the virtual update, and in the virtual update it will be called the move. So again, let's save it, and we should have recovered the movement for the car. Okay, now that we are with the, I have said about the example of the brakes. Okay, let's do the brake thing. Let's assume that we are checking the input. Okay, so if input, to get the input of the user, and we are going to check if the user is constantly pressing, for example, the key. Let's put the brake in the B. Let's take the key codes and let's put it on just on the key B. Okay, and in this particular case, just we are going to show a log message on the console. We are not going to complicate the things. Okay, so user is pressing the brakes. Okay, so what are we doing here? Okay, we are overriding the inherited update. Okay, we are calling to the base because we are still interested to run what it's being executed in the update of the vehicle, but we are extending that behavior with some behavior that only belongs to the car, that it's checking the brakes. Okay, so in this right here we are checking just the brakes. Okay, if the user is keeping pressed B, is that we are braking. Okay, so right now if we go to the Unity editor and press play, and if we press the B, a log message will appear. Okay, if we stop of pressing, the message stop showing up. Pressing again. Okay, let's do a little bit more. Let's go further and let's say, okay, if it's braking, it will display the message, and if it's not braking, then just move. And now, yes, we are going to get the brake functionality right here. So let's press play, and now pressing B. I don't know if you can see, but the car has stopped in its tracks, and I am going to release in 3, 2, 1, and it's moving forward. Again, pressing B, but now it's too small to appreciate, but it has stopped. Okay, so what we have seen here is a way for to inherit behaviors, methods from a hierarchy, in this particular case from vehicle, and a way to override that behavior that we are inheriting to add our own when we need it. In this case, in the case of the car, we needed some functionality that about braking. Okay, so we were able to extend the behavior update with the brake functionality Also taking advantage of, we also take advantage of the update that we inherited from vehicle. Okay, so that's all for the lesson of today. Feel free to experiment, to practice, to just create more overrides on different classes. Just experiment, do your own thing, and try to have a little bit of fun just by programming stuff.